Hello, my name is Benjamin Klein, and in this study, we dissect the nucleus accumbens to ventral tegmental area GABAergic pathway and its potential for playing a role in opioid addiction and reward. So previously, it's been found that GABA reduction within the ventral tegmental area causes the disinhibition of dopamine neurons within this region, which gives rise to anaglysic effects. It's also been found previously that the dopamine neurons within the ventral tegmental area are not only controlled by local GABA interneurons, but also by multiple GABA inputs from different regions as well, one notably being the nucleus accumbens medium spiny neurons. So in our results for experiment 1, we showed through neural tracing that D1 medium spiny neurons do in fact project from the nucleus accumbens to the ventral tegmental area, and through the use of RNA scope in experiment 2, we showed that these D1 neurons also express mu-opioid receptors as well. In experiment 3, we showed that optical stimulation of this pathway is rewarding, and this is seen in two behavioral paradigms: optical intracranial self-stimulation and optical real-time place preference. In experiment 4, through the use of electrophysiology, we showed that optical stimulation of this pathway causes the co-release of GABA and substance P onto dopamine neurons in the ventral tegmental area, giving rise to a biphasic effect. In experiment 5, we showed that the rewarding effects caused by the stimulation can be attenuated by D1, D2, GABA B, and NK1 antagonists. And finally, in experiment 5, we showed that optical stimulation of this pathway potentiates heroin self-administration. So, in this study, we've shown that D1 receptors that are optically stimulated do cause a rewarding effect and increases heroin self-administration. We've also shown that this effect is reduced by D1, D2, GABA B, and NK1 receptor antagonists. And finally, we showed that optical stimulation of this pathway causes the co-release of GABA and substance P that produce a biphasic effect on dopamine neurons within the VTA. So overall, this study really just gives further knowledge and understanding to the neurobiology and the neural circuitry behind opioid addiction and reward.